Good morning, everybody.
Good morning.
Good morning. Today we review for test 3.
Okay, all right.
We have 20 questions, 80 minutes. So 4 minutes for one question. I'm gonna get started now. The first question, solve the following rational inequality, all right? Since the right side of the inequality is already 0, the rational inequality is in the standard form. And we are going to let f of x be the rational function on the left side of the inequality, x minus 4 all over x squared minus 36. Numerator is a binomial prime. I'm going to put a set of parentheses to frame the numerator, x minus 4. Denominator, x squared minus 6 squared can be factored as x plus 6 times x minus 6. As you can see, numerator we have x minus 4, denominator we have x plus 6, x minus 6. So we have 3 critical values for this function. We have x equals positive 4, negative 6, and positive 6. We take the opposites of the 3 numbers I put in red. Okay, 4 is the 0 of the numerator. Negative 6 and positive 6, they are the zeros of the denominator. Okay, the 3 critical values divide the domain of the function into 4 intervals. Knowing the domain of the rational function is not all real. It's all real except negative 6 and a positive 6. So we must have a hole at a negative 6 and a positive 6 to indicate the domain of the rational function is all real except those 2 values. And let's say positive 4 is here. And those 3 values divide the domain of the function into 4 intervals. Interval 1, 2, 3, and 4. And then now we're gonna ready for the chart. We use the sign chart method to solve the inequality. The first row, we have the domain divided into 4 parts. Negative infinity to negative 6, open. And from negative 6 to positive 4, open. And here, 4 is a 0 of the rational function. And then from 4 to 6, open. And then from 6 to positive infinity, open. So 1, 2, 3, 4. 4 intervals, 1, 0. And that's the domain. In the first row, the domain is divided into 4 intervals, including a 0. The next row, we are going to pick testing points inside each interval. And we can take negative 10. From negative infinity to negative 6, we can take negative 10. From negative 6 to positive 4, we can take 0. From 4 to 6, we try 5. From 6 to positive infinity, we do 10. All right? And the next row, we are going to have f of x in the factorial form. Numerator x minus 4. Denominator x plus 6 times x minus 6. I'm going to use the color scheme. This is the yellow. The numerator is yellow. This is the green. This is blue. Let's do blue. Okay. We want to know the sign of the function when x assume those testing points. All right. So let's analyze. When x equals negative 10, numerator is negative. When x equals negative 10, yellow, negative. Denominator, the green is negative. The blue is also negative. Okay, everything's negative. We have 3 negatives. 3 is an odd number, so negative, right? Numerator is a negative, denominator is a negative times negative, which is a positive. So denominator is a positive. Numerator is a negative, denominator is a positive, so the quotient is negative. When x equals 0, yellow negative, denominator green positive, blue negative. So we have 2 negative signs, 1 positive sign. 2 is an even number, so it's going to be positive, all right? Yeah. So next one is 5. At 4, the function assumes 0 because 4 is a 0 of the rational function. When x equals 5, the representing point or the testing point of the interval. When x equals 5, yellow positive, green positive, blue negative, 1 negative, so this is negative. The last one, 10. When x assumes 10, numerator yellow positive, denominator green positive, blue also positive, so everything is positive. All right, so we have the sign determined. And now let's go back the question. What was our goal? Our goal is to find the interval in which function f is bigger than or equal to 0. So we are solving f of x bigger than or equal to 0. Bigger than means positive. Bigger than 0 means positive. Or equal to 0. So we are going to find the interval or point, the function is positive or 0. Sorry, here is 0, okay? Positive or 0. So let's see the last row. The last row. I'm going to use a strong color. This is negative, we don't need it. This one is positive. This one is 0, okay? Positive or 0, that's fine. This is negative, we don't need it. And this is positive. Double check. So this is positive, this is 0, and this is positive. We have 2 negative, we don't need it. So we are going to take the union of the highlighted interval. So -6 to 4. Since we have a 4, since the function equals 0 at the 4, so 4 is going to be included. So at the 4, we have a closed interval. So from -6 to 4, and then include the 4, so we have -6 to 4, left open, right closed. Union 6 to past infinity. Okay, 6 to past infinity. 6 to past infinity is all open. And that's the result. That's the solution set of the original rational inequality in the interval notation, right? Well, we spent like 7 minutes for this problem. We're gonna move on to the next problem. Question number 2. This is a rational function. We need to find the vertical asymptotes, horizontal asymptotes. Okay, this one is not too bad. We need to factor both top and bottom, okay? I'm gonna use my method to quickly factor the top and the bottom. Numerator, quadratic trinomial, 1, 2, 3, 3. So 1 times 2 is 2. -3 times 3, -9. -6 plus 3, -3. So we have x minus 3 times 2x plus 3. That's the numerator. Denominator, also quadratic trinomial. 1, 3, 2, 5. Negative, negative. -6, -5, -11. Positive 10. Okay. So the bottom can be factored as x minus 2 times 3x minus 5. Since top and bottom do not have a common factor, so this rational function does not have any holes, okay? But it will have vertical asymptotes and horizontal asymptotes. Since the denominator, we have 2 factors, right? I'd like to highlight them in red. For this one, we would have to solve. So the vertical asymptotes occur at x equals 2 and 5/3. Because positive 2 will make this factor be 0, right? And 5 or 3 will make this be 0. Well, this just take a little just effort. Make 3x minus 5 equals 0, plus 5 plus 5, we have 3x equals 5 divided by 3. We have x equals 5/3. So the function has two vertical asymptotes, x equals 2 and x equals 5/3. All right. What about horizontal asymptotes? I would look at the original rational function for the horizontal asymptote. Since the numerator has degree 2, denominator also has degree 2, then the horizontal asymptote is y equals the quotient of the two leading coefficients. Numerator, the leading coefficient is 2. Denominator leading coefficient is 3. 2 over 3. Y equals 2 over 3. That's the horizontal asymptotes. All right? Because the behavior and the behavior of the two polynomials depends on the leading term. Since they have the same degree, so the function approaches to 2/3 when x approaches infinity. And that's this problem. This one doesn't spend too much time. All right. Let me know if you have any questions, if you any quick questions. All right. And that's it. Move to the next one. Excuse me. Here we have a rational function. We need to find the following 4 parts. Okay. Part 1, y-intercept. Part 2, x-intercepts. Well, doesn't matter what type of function, finding the x-intercepts and the y-intercept, we have the same method, right? We have the same Q. To find a y-intercept, we make x be 0, okay? To find a y-intercept, make x be 0 in the function. Then we have a y, f of x is y, right? We have a y equals, since x equals 0, that means this part disappears, becomes 0. This part becomes 0. This part becomes 0. This part becomes 0. So numerator, we only have 3. Denominator, we only have 10. So 3 over 10 would be the value of y when x equals 0. So the y-intercept at a point, this specifies a point. So I believe you're gonna enter an ordered pair like this, okay? At a point 0, 3 over 10. It's also important to read the information, the structure, the instruction, provided the answer in the form that required by the question. All right. So that is the y-intercept. The second part, x-intercepts. It has more than 1 because the numerator is quadratic, and we should be able to factor it, right? Okay, let me show you how do we find the x-intercepts. To find the x-intercepts, make y be 0, all right? Make y be 0. Since this is a rational function, numerator 2x squared plus 5x plus 3, denominator 2x squared minus 9x plus 10. Make the function equal 0, make y be 0. If you want to make a quotient be 0, the numerator has to be 0 and the denominator has to be non-zero. Denominator can never be 0, okay? Otherwise it's undefined. So we need a numerator be 0. We need a numerator be 0. So the numerator with better, factor, just in case the numerator and the denominator has a common factor. In that case, x cannot assume the value that will make the common factor be 0. So very careful. We need to factor the top and the bottom. 1, 2, 1, 3. 2 plus 3, yeah. So the numerator can be factored as x plus 1 times 2x plus 3. The denominator, 1, 2, 2, 5, negative, negative, -2, -5, positive 10, -4, -5, -9. So the denominator is x minus 2 times 2x minus 5. Well, numerator, denominator do not have common factor. So we can just make the numerator be 0. We can make the numerator be 0. Just to let you know, in case top and the bottom have a common factor, then that number is not going to be x-intercept, all right, that value, because it's gonna have a hole there. So we make the numerator be 0. When this factor be 0, x assume -1. To make this factor be 0, x assume 3 halves, negative 3 halves, sorry, negative 3 halves. So the function has 2 x-intercepts at the points. The first point, -1, 0. Second point, -3/2, 0. Read the question carefully to see how you enter the answer. It should tell you, do you need a comma between the two points or not, all right? Yeah, you're gonna have to look at the question. I don't have here. Question part number 3, vertical asymptote. While we have the denominator factored already, we look at the denominator. Which two values will make the denominator be 0? Positive 2, right? So x equals 2. Yeah, this one says give the left vertical asymptote first. Okay, so the order matters. So we have 2 vertical asymptotes. X equals 2. The other one is x equals 5/2. 5/2 is 2.5. So 2 is less than 2.5. We give 2 first, and then 5/2 after. Vertical asymptotes add 2, 5/2. Give the left vertical asymptote first. Oh, you know what? Here. And, you see that? And 5/2. Okay? Part 4. We need to find a horizontal asymptote. To find a horizontal asymptote, look at the original form of the rational function. Numerator degree 2, denominator degree 2. So the horizontal asymptote would be the quotient of the two leading coefficients, y equals 2/2, which is y equals 1. Horizontal asymptote at 1, right? Yeah, again, pay attention to the form of the answer that required by the question. All right, so this is the problem, a lot of information. Number 4, find the domain of the function. What is the only value of x not in the domain? This one is easy, guys. All real except -4/7. How do you get that? Denominator 7x plus 4, right? If we let the denominator be 0 and we solve the equation, and we would have 7x equals -4, and divide each side by 7, we have x equals -4/7. X cannot be -4/7. Because if x equals -4/7, the denominator will be 0, and that is not well defined. So the domain is all real except this value. What is the only value of x not in the domain? This value, okay? That's an easy one. Number 5. Select the expressions that are polynomials. There may be more than one correct answer. This question basically is from Foundation 2. And the class right before the spring break, I covered the definition for polynomial. I started with monomial, binomial, trinomial, and a general polynomial. So knowing the exponent on the variable x has to be whole number. 0, 1, 2, those are whole numbers. You cannot have x to the power of half. That's not polynomial. Or you cannot have x equals x to the power of -3. That's not polynomial. So for this problem, I would let you to look at the video or review what you have learned from Foundation 2. Question number 6. Solve this rational inequality. On the right side of the inequality, we have 94. It's not 0. So the rational inequality is not in the standard form yet. Well, it's going to take a little bit effort to rewrite the inequality in the standard form. It's going to be a little bit time consuming. So to do that, we plus 4 to each side. then the right side would be 0. The left side would be x plus 7 all over x plus 1 plus 4 here. We can write 4 as a 4 over 1, all right? And then I'm going to rewrite the 4 again. 4 over 1. I'm going to multiply both top and bottom by x plus 1. I'm going to multiply both top and bottom by x plus 1. To make the two rational expressions have the same denominators. Since now they have the same denominators, we are going to keep the bottom, solve the top, x plus 7 plus 4 times x plus 1. All right, and we need to take a little bit of time to simplify the numerator. I can do that right here, like my scratch paper. X plus 7 plus distribute 4 times x, 4x, 4 times 1, 4. X, 4x, 5x, 7, 4, 11. 5x plus 11. Double check, 5x plus 11, okay? And the denominator is x plus 1. So this work, like upfront work to rewrite a rational inequality in the standard form is very, very important. And it's a good idea to double check. Just give me 1 second. Let me quickly double check it. X plus 1, x plus 1. So x plus 1 on the bottom. Numerator x plus 7. 4x plus 4. So 5x plus 11. Okay, that's correct. And now we have the inequality in the standard form. We let the left side be the rational function f. We have 5x plus 11 on the top. We have x plus 1 on the bottom. And the numerator has a 1, 0, which is a negative 11 over 5. The denominator has 1, 0, which is negative 1. In other words, negative 11 over 5 makes the numerator be 0. Negative 1 makes the denominator be 0. Negative 11 over 5 is about equal to negative 2.2. So this number is smaller than negative 1. So in the real number line, on the real number line, negative 11 over 5 is to the left side, is to the left of negative 1, all right? Since negative 1 will make the denominator be 0, we have a hole here. Negative 1 is not in the domain. The domain of the function is all real except negative 1. And then the two values here divided the domain of the rational function into 3 parts. Part 1, part 2, and part 3. And now we're ready for the sign chart method. Let's make the chart. X. So the first interval, negative infinity to negative 11 over 5. And negative 11 over 5 is a 0 of the top, so it's also a 0 of the function. And from negative 11 over 5 to negative 1, from negative 1 to past infinity, 1, 2, 3, with 1, 0. Okay, that's the first row. Second row, testing points. We want to get negative 10 from the first interval. We can get negative 2 from this interval. Yeah, again, negative 11 over 5 is bigger than, is less than negative 2. So negative 2 would be in the middle of negative 11 over 5 and negative 1. So this is negative 2.2. Negative 2 is in the middle of negative 2.2 and negative 1. And here we can use 0. All right. So those are the 3 testing points for the 3 intervals. And the next row, we are going to have f of x in the factored form. Numerator, look at the top right, 5x plus 11. Denominator, x plus 1. I'm going to use my color scheme. How about numerator, blue? Denominator, yellow? Okay. When x equals negative 10, numerator is negative. Well, it's not too difficult. Okay, even x has a coefficient 5. 5 times -10, -50. -50 has a bigger absolute value than 11, so it's negative. Numerator blue, negative. Yellow also negative. Okay? Numerator blue, negative. Yellow also negative, so the quotient is a positive. We have positive here. And the function equals 0 at -11/5. And now let's look at the testing point 92. When x equals 92, blue is a positive. 5 times -2, -10. And -10 plus 11 is going to be positive. Denominator, yellow, is a negative. Negative. So the quotient is negative, all right? The last interval, testing point 0, when we plug in the function, numerator blue, positive. Denominator blue, positive. Positive, positive, so is positive here, all right? So that's the function, that's the sign of the function in the three intervals, also the 0. And what are we looking for? Look at the top right. We are looking for intervals or values to make f of x less than, strictly less than 0. So we only concern the negative part, or we only concern the intervals, the function is negative, okay? Let's see. Function is negative. Okay, this one is negative, right? 0 doesn't work. Positive doesn't work. Positive doesn't work, 0 doesn't work, so only this part. So the solution set is an open interval, -11/5, comma -1. All right? Okay, let's move to the next problem. Question number 7. Write an equation for the degree 4 polynomial graphed below. Important, we need to identify the 4 zeros. As you can see, we have one here, 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 here. So the 4 zeros are 94, 93, +2, and +4. I'm going to take their opposites. +4, +3, -2, -4, and then put the x in front of each one, and put a parenthesis to frame each one, and then let them multiply them together, right? And we need to put an a in front of the product. A, what is A? A is the leading coefficient. We need to know the value, of course. How do we know the value of the leading coefficient? We use the y-intercept. The y-intercept is here. I would say that definitely, hold on. It looks like a 4. Yes, it is 4. So the y-intercept is 0, +4. So that means if we make x be 0, y should be 4. So let's do so. Make x be 0, then y, the left side y equals 4. So 4 equals 8 times, make x be 0, okay? We have 4 times, 3 times, 92 times, 94. And then we have 4 equals 8 times. Let's see what is the product here. Well, actually, we can get rid of 4 first, right? Both left side and right side has a 4, so I can get rid of them. We have 1 equals 8 times, and this is going to be positive because we have 2 negative numbers. 24. 3 times 2, 6. 6 times 4, 24. Positive. So left side is 1, right side is 8 times 24. We can solve A as A equals 1/24. That's how do we find the leading coefficient. So the equation for the degree 4 polynomial is going to be y equals, knowing they already have a y equals, you don't have to enter y equals. Okay, otherwise the system marks that as wrong. Is equal to 1/24 times x plus 4, x plus 3 times x minus 2 times x minus 4. All right, that's it. Degree 4, 1, 2, 3, 4, 4 zeros, and the leading coefficient 1 over 24. Satisfy all the information given from the graph. That's question number 7. Okay, we are not falling too behind, so it's good. Number 8, the cost C in dollars for a company to produce and sell X thousand gadgets is given by this function. C here, cost. X here, number of products that is produced. Of course, is in thousands. So this is the function connecting the cost and how much product you produce. It makes sense. The cost depends on how many products you produce, right, in the factory. So this is a function. The independent variable x is the number of items you produced, you manufactured. It is a quadratic function. This is about quadratic function application. The leading coefficient of the quadratic function is positive, so the graph of this function is a vertical parabola opens upward. Okay, what is the company's startup cost? C is cost. Startup cost means the value of C when x equals 0. When x equals 0, C equals 3550. That's the startup cost, means before you even produce anything, before you even start to manufacture any products, you have to spend $3,550,000. Okay, like you have to rent the land or buy the land and then make the factory, hire people, everything. So that's the startup cost. Part B, what is the minimum cost? Knowing cost is the Y value. We want to know the minimum cost, means we want to know, we want to know I apologize. We want to know K. We know H comma K is the vertex, right? Part B, what are we looking for part B? Part B is to find the K, because K is the minimum value of C, of the cost of the function. Well, how do we find the K? The function is given, the polynomial, the quadratic function is given in the standard form, not a vertex form. One way to do that is to rewrite or use completing square technique to rewrite the function in the vertex form. Another way to do that, guys, is you know H here is negative B over 2A. If you know this formula, it might make your job easier when you encounter a problem like this. And it's not very difficult to remember this formula, because remember the famous quadratic formula, negative B plus minus square root of delta, which is B squared minus 4AC all over 2A. If you make this part be 0, X is negative B over 2A, and that is H, okay? And then I think I'm gonna use this method just to speed it up. And we know A, I'm gonna write a standard form AX squared plus BX plus C here. So we know A equals 1 over 50, A equals 1 over 50, B equals negative 2, C equals 3550. And we only need the AB, we don't even need a C. So we plugging in, we have B equals negative 2. We have 2 times A equals 1 over 25. A is 1 over 50, twice of it is bigger, so it's 1 over 25. And the negative cancel negative, so we have 50 here. Yeah. But because you can use keep changing flip, right? 25 will become on top. 2 times 25 is 50. So H is 50. But we want to know K, right? and we're plugging in h is 50, x equals 50, then we would know the value of k. We can do that. So let's plug in x equals 50 quick. And we have 1 over 50. Here we have 50 to the power of 2 minus 2 times 50 plus 3550. And 50 square over 50, so we have 150 here, minus 100 plus 3550, and minus 50 plus 3550, and we end up with a positive 3500. And that is the minimum cost, 3500. How many gadgets must be sold in order to incur the minimum cost? 50. All right, you're gonna have 50 here. I'm going to just give me 2 minutes. I'll be back soon, okay? Okay, I'm back. This is number 8. Number 9, find all zeros for these polynomial functions. All right, degree 3. So we look at the function, you know we're gonna lucky because this function is factorable. Should be very easy to factor by using the method of grouping. If we group the first 2 terms, x cubed minus 4x squared, and we group the last 2 terms, x minus 4. The first 2 terms, x cubed minus 4x squared, has GCF x squared. We can figure it out. Then inside the parentheses, we are going to have x minus 4. And now those 2 parts have a common binomial factor x minus 4, right? We can factor x minus 4, and we would have x squared plus 1, right? Okay, so obviously, the opposite of this number, I just put it in red, which is a 4, is a 0, right? Is a 0. So we got a 1. This polynomial function has degree 3. So it should have 3 zeros in a complex number set. We already got a 1. The other 2, look at this factor. We're going to make that yellow as 0. Make x squared plus 1 equals 0. Minus 1 minus 1. We have x squared equals -1. That means x equals plus minus root -1. Do you guys still remember what is root -1? We define the imaginary unit I as root -1. So we have x equals plus minus I. Yes, those are the other 2 zeros. So we have 4I, negative I. So 3 zeros. Okay? Yeah, it says enter the zeros separated by commas. So you can write 4, comma, I, comma, negative I, and that's it. Question number 9. Let's go to question number 10. Solve the following quadratic inequality. I changed this because this the actual problem on the exam is less than 0. Just to make it more more authentic. This is a quadratic inequality. The left side is a quadratic trinomial. Let f of x be the left side, which is 5x squared plus 9x minus 2. Let's factor 1, 5, 1, 2, negative. So, let's see, 2, 1. 10 minus 1 is 9. 2 times -1 is -2. 10 minus 1 is 9. 1 times 5 is 5. So after we factor the quadratic function, we have x plus 2 times 5x minus 1. And this function has 2 zeros. The 2 zeros are -2 and 1/5. -2 make the first factor 0. 1/5 make the second factor 0. Okay, 5x squared plus 9x minus 2. Yeah. So we have 2 zeros, and the 2 zeros divide the whole real number line, which is the domain of the polynomial function, into 3 intervals. Interval 1, 2, and 3. Okay, sign chart method. You can use different method, but I like the sign chart method. It's a very good method. So I'm going to keep using the same method. The first interval net infinity to -2, we have 0 at -2, and from -2 to 1/5 open, and then we have 0 at 1/5, and from 1/5 to past infinity open. 1, 2, 3, 3 intervals, 2 zeros. Next row, testing point. Net infinity to -2, let's do -10. And -2 to 1/5, let's do 0. 1/5 to infinity, we can do 1, or we can do 2. Do 10, it doesn't matter. We can do 1 here. And the last row is the function in the factored form, which is x plus 2 times 5x minus 1, 5x minus 1. And color. First factor yellow, second factor blue. They are multiplying together. When the testing point is 10, yellow is negative, blue is negative, right? Yeah. Yellow is negative. When we plug in x equals -10, blue is negative, so negative times negative positive. At -2, function is 0. At 0, when x equals 0, yellow is positive, blue is negative, so negative. When x equals 1/5, 0. When the testing point is 1, when x is 1, yellow positive, blue positive, so positive. So that is the sign for the function in the intervals, and the zeros. What are we looking for? We are looking for intervals or function or values to make f of x strictly less than 0. Means we want the intervals or values at which function negative. We only want a negative. We only want a negative. So let's see. We only want a negative. Positive, no. 0, no. Negative, this one's negative. 0, no. Positive, no. Oh, okay. So that's it. So the solution set of the function is -2 to 5th open interval. Okay, open interval because strictly less than 0. And that's question number 10. We have done. Okay, not too bad. We use 43 minutes, so we're on track. Question 11. Consider the parabola given by the equation f of x equals 4x squared minus 14x minus 9. Answer the following for the parabola. The graph of the parabola opens upward. You can choose one, down or up, because the leading coefficient is 4 positive, so it opens upward. Give the domain of the function using interval notation, all real. Quadratic function, same with all other polynomial function, the domain is all real always. Doesn't matter the degree. Part C, give the range of the function using interval notation. Okay, range is not all real. Range is not all real. Okay, so how do we find the range? The range is what? K to infinity. What is K? H comma K is a vortex. Since the parabola opens up, it has a minimum value, right? So the minimum value of the function is k. The range is from k to infinity. So we need to find out what is k. Same with, we have a similar question. You can complete the square, write the function in the vertex form, and identify k. Another way to do that is use the formula. I can do that again. I think this is easier, actually, is easier for you. 4x squared minus 14x minus 9. Okay, I'm going to write the standard form of the quadratic function on the bottom, and you can know what is A, what is B. A is 4, B is negative 14. H is negative B over 2A. Okay, so negative B is negative 14. And A is 4, twice of A is 8. 2A is 8. So positive 14 over 8, divided top and bottom by 2, 7 over 4. 7 over 4 is H. 7 over 4 is H. And if we plug in H equals 7 over 4, or X equals 7 over 4, just a different letter. And let's see what we have. Y. Y is going to be 4. X is 7 over 4 to the power of 2 minus 14 times 7 over 4 minus 9. Depends on you. Sometimes plugging is easier, like previous, the cost function is plugging actually is quite easier than completing square. And this one, since it has fractions, maybe you would consider, maybe try the completing square. You can do that later on your own. So now I use this method. I plug in H 7 over 4. Yeah, let's keep going and find the value for Y, which is the K. So 4 is 4 over 1, 7 over 4 square, so 49 over 16, minus this 14 over 1, 7 over 4 minus 9. And this 4 cancel, this 16 becomes 4, so 49 over 4, minus this becomes 2, this becomes 7, so 49 over 2, 49 over 4, and then minus 9. So knowing 49 over 2 is twice of 49 over 4. So we have a negative 49 over 4, and then minus 9. Okay, and both of them are negative. We can rewrite 9 as 36 over 4. 36 divided by 4 is 9, right? And they have the same denominators. Keep the denominator 4. Negative 49 minus 36, that gives us negative 85. It's not a very convenient number. Negative 85. So that is K. That is K. So the range is negative 85 over 4 to past infinity. Okay. You know this one, if I completing square just very quickly, give me some time. X squared minus 7 over 2, because 14 over 4 is 7 over 2. X and minus 36. Hold on, 9 over 4. 9 over 4. Then we can minus 7 over 2x plus is gonna be square and minus 9 over 4. Those completing square and those two should be give k me just double check very quickly. And so it's negative 49 over 4 minus 9. Yeah, same thing, guys, same thing. The result is correct, all right? And consider how much work for each method. I think is similar. You cannot avoid to handle fractions, unfortunately, because the leading coefficient is now 1 is 4, so you have to factor it out and then completing square. You still have to deal with the fraction. So I still think use the formula is even still better. You do need you cannot avoid using fraction anyway. All right, so that is the range. Range is from the minimum to all the way to infinity. And so that is the part C. Okay, that's everything for that question. Next question, number 12. According to the rational roots theorem, which of the following does not represent a possible pair of rational roots of this polynomial? Okay, so numerator. So remember P over Q equals plus minus. Numerator, we're going to have the factors of the absolute value of the last term, right? The last term absolute value is 6. So 1 is a factor, 2 is a factor, 3 is a factor, 6 factor. All right. Do not consider sign because we already have the sign taken care of in front of the braces. The denominator is going to be the factor of the leading coefficient, 35. 1 is a factor, 2 is not, 3 is not, 5 yes, 4 is not, 5 yes, 6 is not, 7 yes. I think, and all the way to 35. So those are all the 4 factors of 35. 35 can be factored as 1 times 35, can also be factored as 5 times 7, so 4 factors. As you can see, this one, the denominator is 2. That wouldn't work. 2 is not appear in the denominator. And plus minus 6 over 1, that is fine. Plus minus 2 over 7, that is fine. That is fine. This one, 3 over 7, that is fine. Plus minus 3, 3 over 1, that's okay. 3 over 20, 3 over 35, that's fine. 1 over 5, that's fine. 2 over 5, that's fine. 6 over 35, that's fine. 1 over 7, that's fine. Only this one. I think this is a multiple choice question, right? Then should be only one answer choice, which is not possible rational zero of the given polynomial function. Next, question number 13. The polynomial of degree 3, P of x, has a root of multiplicity 2 at x equals 2 and a root of multiplicity 1 at x equals -2. The y-intercept is negative 1.6. We need to find a formula for the polynomial function with degree 3. Okay. All right, so it says it has a 0 at 2, and the multiplicity is 2. That means it has 2 2's, right? 2 2's. And a root of multiplicity 1 at -2. Well, let me double check. So has a root of multiplicity 2 at 2. So 2 2's. And root of 1, a root of multiplicity 1 at -2. Okay, so those are the 3 zeros. 3 zeros. And we can take the opposites of the 3 zeros, -2, -2, +2, and then put the x. This is always what I do, right? X, and put them together. So degree 3. And leading coefficient is -1.6. And this could be only this part. And very important, the function already have P of x equals. You do not do that again. Or you do not enter y equals. That will definitely make your answer marked as wrong. So would you need to factor it out? I mean, rewrite the function. The polynomial of degree 3 has root. It doesn't say, right? Oh, my bad. Almost made mistake. This is not leading coefficient. I read it wrong. Leading coefficient is A. The y-intercept is -1.6. So we have to solve for A by using that piece of information. We have seen similar thing earlier in the package, right? So y-intercept is -1.6 means when x equals 0, y is -1.6. So when x equals 0, so -2, -2, +2, -1.6. -2 times -2 is positive 4. 4 times 2 is 8. So 8, 8. And then we divide each side by 8. Cancel. We have a letter A equals -0.2. A equals -0.2. That's the leading coefficient, -0.2. So the function should be -0.2. If you want, you can write x minus 2 to the power of 2. And then times x plus 2. I think you probably do not need to factor it out, like multiply it out. This would be good enough. I think this is good enough. I think I tried. Okay, so that's it. This one is not very challenging. It is a good problem, but not very challenging. That's number 13. Let's move on. Number 14. Write an equation for a rational function with vertical asymptotes at those 2 points, and x-intercepts at that, and y-intercept at 4. Okay, it's rational. Rational function f of x. So numerator has a polynomial, denominator has a polynomial. It says the function has 2 vertical asymptotes. It doesn't have holes. It doesn't say it has holes. So we are certain the denominator is going to be x minus 5, x plus 1. Okay? Take the opposite of 5, -5. Opposite of -1 is +1. So the denominator is going to be x minus 5, x plus 1, because it has 2 vertical asymptotes at those 2 points. So that's denominator. How do we find the numerator? X-intercepts at x equals -6 and x equals -5, right? So let's take the opposite of the 2 numbers, +6, +5. So the numerator is going to be x plus 6 times x plus 5. Be careful with the sign. I think my method might help to avoid making sign error. You take the opposite first and then put the x in front of the numbers in red. So far so good. Y-intercept is 4, so we don't know the leading coefficient. How about we have leading coefficient here? And how do we know the value of A? And we use the information y-intercept at 4 to find the value of A. Find the value of A, yeah. So since y-intercept is 4, is at 4, so that means the graph passing through 0, 4. That means y equals 4 when x equals 0. Y equals 4 when x equals 0. So left side y equals 4, and we have A here, and we're going to make all the x be 0, right? Then we have 6 on the top, 5 on the top, multiply together. On the bottom, we have -5 on the bottom, 1 on the bottom. And 5 cancel 5. We have -6, so 4 equals -6a. This cancel, right? Is negative, -6a. And divided by -6, divided by -6, cancel. We have a equals -2/3. A equals -2/3. That's the leading coefficient. So you can write A here. Now you can fix it as -2/3. 2/3, you can put 2 on the top. You can put 3 on the bottom. And knowing you have a negative sign. I think that's good enough. And you're going to enter this part in the cell. Very important. If the system already have a y equal, do not do again y equal. Okay? And I think we have this question done. Write an equation for a rational function with. This is good. Do you need a, multiply it out? I think this is good enough. If you concern this in the exam, after the exam, email me. I can look at your test if simply because of the form the system took out the points, I can override that. So be aware of that. I think this is good enough. Okay, next 15. Consider the polynomial function degree 8. Leading coefficient is 94. This is about end behavior of a polynomial function. The end behavior of a polynomial function completely determined by the leading term. I highlighted in pink, 94p to the power of 8. When p approaches infinity, let's see what happened to the leading term, okay? When p approaches negative infinity, p to the power of 8 approaches to positive infinity because 8 is even. All right, 8 is an even number. And 4p to the power of 8 times 4 still positive infinity. But if we multiply 91, change the sign, then it's going to approach negative infinity, right? So when p approaches negative infinity, the function is actually y value. The function approaches infinity. So you should choose negative infinity here, negative infinity. And now let's see the end behavior of the function when p approaches positive infinity. When p approaches to positive infinity, without the sign in front of it, defaulted as positive infinity. P to the power of 8 approaches to positive infinity. 4 multiplied by 4 still approaches to positive infinity. But now you change the sign, this is going to approach to negative infinity. All right? So when p approaches positive infinity, the function also approaches to negative infinity. So basically, it's gonna be like an M shape like that. Yeah, when p approaches negative infinity or positive infinity, the function approaches to go down, negative infinity. It's degree 8, okay, maybe not 4. Degree 8 is gonna be more complicated in the middle, but the end behavior is go down. The end behavior is go down on each side. Okay, on each side. Is this clear? So when p approaches net infinity, you're going to choose net infinity here. That's where the function approaches to. When p approaches past infinity, f of p also approaches net infinity. Okay, I don't think this one is very challenging. It's actually very good because you need to have that thinking when you go to calculus, when the variable approaches to infinity. Next question, number 16. The polynomial of degree 5, p of x, has a leading coefficient 1, has roots of multiplicity 2 at 2, okay? So means it has 2 as a 0. 2 of them has roots at 2 with multiplicity 2. And 0, okay, means 0 also 2 appears twice. And a root of multiplicity 1 at -4. Okay, it's degree 5, right? Degree 5, and we found all the 5 zeros. 2, 2. Yeah, has roots of multiplicity 2 at 2 and 0. Okay, 2, 2, 0, 0, -4. So those are the 5 zeros. Very good. The 5 zeros change their sign, -2, -2, 0, 0, or -0, -0, +4. And put the x in front of it. If you wanna, rewrite the multiplication as exponential expression, because the same, right? So square. And x minus 0 just x times x squared, and x plus 4. You can rewrite it like this. And the leading coefficient is 1, okay? It's 1. The polynomial of degree 5 has a leading coefficient 1, has roots. Find a possible formula for p of x. Okay, so this could be the answer. You don't have to have the 1, by the way. Put it here. Do not rewrite p of x. They already have p of x equals. You just need the right side. Number 17. This is a quadratic function. Since the leading coefficient is negative, the graph is going to be a parabola, opens down. The direction of the graph is like which of the following? We only have two options, of course, this one, right? Opens down. And the y-intercept is, oh, we have to figure that out. Let me, this is so big. Let me make it smaller. I mainly want to know the function. I can see it. So the function f of x, I'm going to rewrite it. F of x equals negative 2x squared plus 8x minus 9. Negative 2x squared plus 8x minus 9. Okay? So we know the direction of the function opens downward. Next part, find the y-intercept, and find the x-intercept, and find the vertex. Okay? To find the y-intercept, make x be 0. If we make x be 0, disappear, we have negative 9. So 0, comma, yeah, so at y equals negative 9. So in this problem, it says the y-intercept is at y equals, that means it's going to be a value. That means you do not enter 0, negative 9 like that. You really have to get what the question intend for you to what the question intend for you to enter. This time just one value, not 0, negative 9. All right. So that is the y-intercept. X-intercept, we make y be 0. The x-intercepts are x equals. Okay. So make y be 0. We have 0 equals negative 2x squared plus 8x minus 9. I'm going to move the three terms to the left side and change their signs. 2x squared minus 8x plus 9 equals 0. I want a 0 to the right anyway, and I need the leading coefficient positive, so it's good. Just use the, move them to the right, to the left side. 2x squared minus 8x plus 9. And let's factor. We have the factor 1, 2, 3, 3, negative, negative, negative 6, negative 3. Hold on. 1, 2, 3. 1, 2, 3, 3. Let me check the delta here, all right? A is 2, B is negative 8, C is 9. Delta is B squared minus 4AC, B squared negative 8 squared minus 4AC. Be very careful. The calculation minus 4, A is 2, C is 9. 64 positive, and then minus 72. Oh, okay. It's not factorable. It's going to have imaginary solutions. Non-real complex. So negative 4 times 2 is 8. 8 times 7 is 72. 64 minus 72 is a negative. Negative what? 8. Negative 8 is less than 0. What does that mean? That means the graph of the parabola is like this. I give you the I give you 6 graphs. I give you 6 graphs. The y-intercept is 0, negative 9. So down here. It's like this. Because leading coefficient less than 0. And also delta less than 0. So the graph does not cross x-axis. There is no x-intercepts. There isn't x-intercepts. Let me see. When I try to make y be 0, then this is called 0. And I try to solve the equation, I don't have a real zeros. If I double check this one, A is -2, B is +8, C is -9. Should give me the same thing. Delta B squared minus 4AC, B is 8 squared minus 4AC, 64, negative. Yeah, it's the same thing, less than 0. Yeah, so there's no. So how do you write it, NA? I believe the question will tell you how to write it, all right? It will tell you if it doesn't have x-intercepts, then you choose whatever. And what about the vertex? Again, for vertex, you can do completing square, or you can use the formula that I gave you earlier, right? So I'm going to write the function again because I need to see it better. That is 2x squared plus 8x minus 9. Double check. That is 2x squared plus 8x minus 9. Okay, so A equals -2, B equals +8. So H equals -B over 2A. B is 8. A is -2. Twice of A is -4. So it's +2. Double check. -8 on the top. -4 on the bottom. So H is 2. So let's plug x equals 2 into the function. Then we would have our K. K would be equal to -2. So H is 2, plugging in to replace X is also 2. And be very careful with the calculation. This is really test your algebraic ability. Can you do this work? 2 times 2 is 4, so -8 plus 16 minus 9. And we have -1. Because -8 plus 16 is +8, +8 minus 9 is -1. So that is K. H is 2. K is -1. So the vertex is 2, -1. Is below, is in quadrant 4, below x-axis. Yeah, everything is consistent. So this is going to be the answer for the vertex, 2, -1. All right. So figure out how do you enter anything when the x-intercepts do not exist. Oh, maybe you have option to write dnx does not exist. DNE does not exist. All right, we need to hurry up. Next question, number 18. This is a rational function. Y-intercept. Y-intercept make x be 0, right? Make x be 0, disappear. Then what's the y value? -6/2, -3. Very straightforward, this one. At the point 0, -3. So that's y-intercept. A lot of questions in the exam about x-intercept and y-intercept, right? X-intercepts at the points is better. We factor the numerator and the denominator. Factor 2 out, we have 2x minus 3. Factor -2 out, we have x minus 1. They do not have a common factor, so we can safely say the x-intercept at 0 at 3/2, 0. Because 3/2 will make this part be 0. If you are not sure, make a 2x minus 3 equals 0, plus 3 plus 3. We have 2x equals 3/2/2, so x equals 3/2. X equals 3/2. When x equals 3/2, the numerator is 0, so the function is 0. So that is the x-intercept 1 only. Equation of the vertical asymptote. X equals, it says the equation, so you don't have to enter the whole equation. X equals 1. Because the 1 would make the denominator be 0, right? So x equals 1. Equation of the horizontal asymptote. Let's go back to the original rational function. Since numerator degree 1, denominator degree 1, they have the same degree. then the horizontal asymptote would be the quotient of their leading coefficient. 4 over 92 is 92. So y equals 92. Draw a graph. About the graph, since you have a graphing calculator, I would not worry about that. So I will leave that for yourself because you have a graphing calculator. All right. By first placing the horizontal and the vertical asymptotes, then plotting an additional point on the graph. Yeah, I think you should try that on your graphing calculator. You have the function given. All right, we have 2 more. We have 5 minutes. I'm going to keep going. This one is okay. This one we can do synthetic method to find the quotient and remainder. This is about the division of 2 polynomials. Good thing is the numerator. Good thing is the denominator is in the format x minus k. The denominator divisor is x minus k. K here is 3. So we can use the synthetic method. Check the numerator is already, it's not. The numerator, let's write the numerator as the standard form. X to the power of 4th plus x cubed. We're missing x squared. So the coefficient of x squared is 0. Very important. Otherwise, you mess it up. Minus 40x plus 13. So 4, 3, 2, 1, 0. Okay. And we are going to take their coefficient 1, 1, 0, negative 40, 13. Double check, always double check. 1, 1, 0, negative 40, 13. And the k is 3. So put a 3 here. And let's do our synthetic method. Bring down 1. 1 times 3 is 3. 1 plus 3 is 4. 4 times 3 times 4 is 12. 0 plus 12 is 12. 3 times 12 is 36. Negative 40 plus 36 is 94. 3 times negative 4 is negative 12. 13 minus 12 is 1. Now 0 is 1. Okay. Let me double check. 1, 3, 4, 12, 12, 36, negative 4, negative 12, 1. Okay. So remainder is 1. This is remainder. And the quotient, we look at those 4 numbers. The quotient is going to be negative 4, 12x, 4x squared is a 0, 1, 2, and this one's x cubed. All right, this is the quotient. X cubed plus 4x squared plus 12x minus 4. That's the quotient. Remainder is 1. All right, so that's synthetic method. The last problem, we have 3 minutes. The denominator is not in the format of x minus k, unfortunately. So we would have to do long division. But do long division still require both top and bottom in the standard form. So the numerator, we're going to write it as standard form. 10x cubed plus 31x squared. Missing 0 times x and then minus 8. Double check. Degree is 3, so we should have 1, 2, 3, 4. 4 terms in the standard form. 3, 2, 1, 0. And the long division divisor is going to be 5x plus 3. 5x plus 3. We're going to repeat the process starting with divide. Divide the leading term in the dividend over the leading term in the divisor. 10x cubed over 5x, which is 2x squared. 2x squared, put it here. We want to align like terms vertically. Multiply 2x squared by the divisor, 5x plus 3. Distribute, we have 10x cubed. 10x cubed plus 6x squared. 10x cubed plus 6x squared. Put it under here, cubed plus 6x squared. Minus, subtract, we can do change the sign and adding, or you can just see subtracting. So these two gonna disappear. 31 minus 6, 31 minus 6, 25, double check, 11 minus 6 is 5, yeah, 25x squared. And bring down 0x. And repeat the process. Divide 25x squared over the leading coefficient of the leading term of the divisor 5x, which is the quotient gives us 5x. Put a 5x here. Multiply 5x by the divisor 5x plus 3. Distribute 25x squared plus 15x, 25x squared plus 15x. Subtract, then those two cancel. 0 minus 15, negative 15x. Bring down the next term, negative 8. And repeat the process. Divide the negative 15x over the leading term of the divisor, which is 5x. The quotient is negative 3. We put a negative 3 right here. And then multiply negative 3 by the divisor 5x plus 3. Distribute, we have negative 15. Run out of space. Negative 15x minus 9. Negative 15x minus, this is 3, right? Yeah, minus 9. So we're going to put a negative 15x minus 9 here. And then subtract. Those two terms cancel each other. Negative, be careful. Negative 8 minus negative 9 is a positive 1. It is positive 1. So the remainder is 1. The quotient is on the top. Okay? And we actually finished on time. Very good. Good time management. Repeat watching the recording. Oh, I have a. Do we have access to this study guide PDF or would it Word doc? I don't have any message. Oh, okay. Yeah, you're right. I forgot. I apologize. But now you have the. Yes.
I wasn't able to get all the answers, so I have to go back to the video because I was trying to write the whole question out because I didn't know if we had it or not.
Yeah, I apologize. I forgot. So since now we have the answers, I'm gonna post this in Blackboard. Is okay this afternoon?
Okay.
Okay. Thank you, guys. I'll see you on Thursday. Feel free to email me. Let me see who's attend the class today. Mr. Max, Eliza, and Michael. Okay, cool. See you on Thursday. Bye.
Bye. See you on Thursday.
See you.
Bye.
Bye-bye.
Do I need to email you? I don't think I'll be able to be on to class on Thursday, this Thursday.
Yeah, you need to email me.
Okay.
Okay.
I will do that right now.
Yeah, thank you. See ya.